Okay, this podcast is going to focus in on balancing equations. It's a little different from the other ones because there really isn't a set of PowerPoint slides. I'm mainly just going to use this format to step you through the process of balancing equations. Okay, the first thing to realize is that we balance equations because in chemical reactions, mass is conserved. All right, so conservation of mass is why we balance equations. And basically what conservation of mass says with regard to a chemical reaction is that the number and type of atoms in our reactants is equal to the number and type of atoms in the products. All right. Now, two words that we've used, but let's just clarify for them. When we have a chemical equation, it is set up where we have our reactants on the left side, we have a yield sign in the middle, and then we have our products on the right side. Reactants being the things that we start with, and then the products being what we're left with after the chemical reaction takes place. And the chemical reaction is basically just a rearrangement of the atoms. And so that's why we get conservation of mass, because we're not creating or destroying anything. We're just rearranging atoms in a chemical reaction. And so the number and types of atoms that we start with has to be equal to the number and types of atoms that we end up with. And in order to show that in a chemical equation, we do what we call balance it. So what I'm going to do is there is, next to the link for this podcast, there is a balancing equations worksheet. And I'm going to be using some of the examples off of there. So if you wanted to print that out before you look at this, or you can look at this and then go to the worksheet later. But that's where these problems are coming from on there. Okay, so we're going to start out with the first one on the balancing equations worksheet. And we have silver oxide, and it is breaking apart into silver and oxygen. Okay, I'm going to start out basically using what I call a bookkeeping approach, and where we're going to basically look at the atoms that I have on the reactant side. That's silver and oxygen on the product side. On the reactant side, I have 2 silvers and I have 1 oxygen. Product side, I have 1 silver and 2 oxygens. The key thing to remember here is I already have my balanced formulas written out here. I can't change subscripts when I'm balancing an equation, because if I change a subscript, I'm actually changing what the substance is. So the only thing I can do is I can put numbers out in front of the formula for the compound or the element, and that will multiply through everything that's in the substance, but it won't change the formula. It won't change what the substance is. Okay? Whoops. I didn't mean to do that. Let's do well, I thought I could change the color. There we go. Yeah, let's do some blue. Okay, so typically the process, a good process to follow, or the order in which you are to balance that will help you out, is first balance the metals. Second, balance your nonmetals. And third, well, go back up here, except the nonmetals except for oxygen and hydrogen. You want to balance oxygen and hydrogen last. Okay, and then you're going to be rebalancing as needed. Alright, so let's go through these steps using our bookkeeping method here. Eventually, you should be able to wean yourself off of using the bookkeeping method, but this way kind of helps you get the whole point of what we're doing. Alright, so metals first. Silver. I have 2 silvers on my reactant side, 1. Only thing I can do is make one of them bigger, so I'm going to put a 2 in front of the silver on the product side. That changes this to 2. Okay, so now I'm balanced on my silver, so let's go to the oxygen. I have 2 on the product side, 1 on the reactant side. So I'm going to put a 2 in front of there. So I now have 2 oxygens, but I've also now changed my silver. So I have 2 times 2, or 4 silvers. Okay, so now this is where we have to rebalance. I'm going to go back, and so now instead of a 2 over here, I'm going to make this a 4, which means I now have 4 here, and now they match. 4 silvers, 4 silvers. 2 oxygens, 2 oxygens, so now this is balanced. Okay? Alright, so let's look at another example.